Hello Year 11 and welcome to our third video here for our fourth topic. We're looking at linear graphs again today. We've seen these before. A straight line, y equals mx plus b ideally. Gradient, y-intercept. Yeah, they're the big things about linear graphs, but in fact we might look at them slightly different ways. So, we can quite reasonably sketch a straight line as long as we know 2 points on that line. And we should always, where we have intercepts, indicate those intercepts, right? We should show those on a sketch. So we want to find the x-intercept, we want to find the y-intercept, and they may as well be our 2 points. How do we find the y-intercept? Let x equal 0, solve. How do we find the x-intercept? Let y equal 0, and solve. There's our 2 points, straight line through them, done, boom. There are a couple of exceptions there. Now a vertical line will only cross the horizontal axis. It won't intercept the vertical axis. A horizontal line, the reverse, right? Has a vertical intercept, but not a horizontal intercept. And a line passing through the origin really only has the 1 point. Okay, passes through the origin, so we'd need to find a second point on that line to draw it effectively. As for the vertical and horizontal line, we should be able to recognize those. Vertical lines take the form x equals a constant. Horizontal lines take the form y equals some constant value. So we can recognize and sketch those immediately. And I should just point out that a vertical line, right, such as x equals 3, will fail the vertical line test. Therefore, it is not a function. Let's move on to some examples. Here we go. Let's sketch these. So this first equation here, 2x minus 3y equals 12, if I let x equal 0, then negative 3y equals 12, then y equals 12 and negative 3, y equals negative 4. Okay. And if y equals 0, then 2x equals 12. That means that x equals 6. So there's our 2 points, right? Our 2 intercepts. Our vertical intercept, negative 4, and our horizontal intercept, our x-intercept, y equals 6. I should probably label these things, but I've got a feeling I didn't. Indeed I did not, which is not very sound. But anyway, there's our 2 points and a line going through them. Moving along now to our next line, our next linear relation. I haven't called it a function, just in case it's not a function. Y equals negative 4 is a horizontal line. Okay. It's a horizontal line passes through y equals negative, passes through negative 4. So that's through that point there, and it should look like this. X equals 5 is a vertical line. Vertical line, it's not a function. Fails the vertical line test. It's going to pass through x equals 5. Right? It should look like this. There we go, magic. And it looks to me like there's only one to go, and that is y equals 3x. And if y equals 3x, then I have a, if you like, a straight line with a gradient of 3 and a y-intercept of 0, passes through the origin. We really only need 1 more point. We go across 1 up 3. That's going to indicate a gradient of 3. That point 1, 3 will line the line, as would 2, 6, and so on. And so here we go. Hopefully. Oh, there we go. There's my last line there. And that's us. Done. So a review of linear functions. Vertical lines are not functions. Other straight lines are. We always want to find the intercepts. I find the y-intercept by letting x equal 0. The x-intercept by letting y equal 0. That's it. Thanks very much. See you in class.